Hello, everybody. How y'all doing in TV land? Any questions from what we did last time? Chapter 3, Section 5 or 4.1? Anybody have any questions? Nope. All right. Now look at Chapter 4, Section 2. Let me share my screen here. All right. Chapter 4, Section 2. Graphing polynomials. This is question 1. When we graph polynomials, there are certain things that we have to locate first. So in this case, we're going to look at the maximum number of zeros, the maximum number of x-intercepts, and the maximum number of turning points. So the maximum number of zeros and number of intercepts are the same thing. Zeros are solutions. So solutions are the same things as x-intercepts, which are the same things as zeros. The reason they're called zeros is because when you cross the x-axis, the y value is 0 at that point. So that's when they say zeros, you set the equation, set it equal to 0, and solve for x. So in this one, what's our maximum number of zeros of this one? Yeah, the maximum number of zeros is that largest exponent. Okay, now here's the question. Why does it say the maximum number of zeros? Doesn't this mean there's 5 zeros? No, because what that actually tells us, since it's an odd exponent, we know that both ends point. What's that? Oh. So both ends of our graph point in different directions because it's an odd power. So we can have 1, 2, 3, 4, 5. We can have 1, 2, 3, 4 solutions. One, 2, 3 solutions. One, 2 solutions, or 1 solution. So the maximum number of zeros is also the degree of the equation. The degree is the largest power. The maximum number of x-intercepts is the same thing as maximum number of zeros, which is 5. And the maximum number of turning points, can you remember what that is? the maximum number of turning points. Turning points are the same things as vertices. It's always one less than the number of intercepts. So here's the max number of turning points. Max number of zeros and X-intercepts. So these two are the same as the degree of the equation. Okay. Remember last time we also talked about end behavior. End behavior of a graph. It talks about which directions both ends of a graph point. And this depends on two things: the degree of the polynomial and the leading coefficient. So the degree of the polynomial we call n, that's the largest exponent is n, and the leading coefficient we call a. So with that, we can have a little matrix here. A could be positive or A could be negative. N could be odd or N could be even. Remember, this is always, always, always the leading term, no matter what polynomial you have. No matter how big your polynomial is, the leading term and the constant tell us a good bit of information about where the graph, how it's pointing, and where it crosses the y-axis. So if n is odd, the n behaviors point opposite directions. If A is positive, the left end goes down, the right end goes up. If A, the leading term coefficient is negative, then the left end goes up and the right end goes down. It's a decreasing function. And we don't know what happens inside in the middle. It could be anything. If n is even and A is positive, then we know both of the end behaviors point up the same direction. And if A is if there's a negative coefficient, then they point down. And that's all by looking at the first part of the polynomial, the largest exponent. So with this example, I'm sorry, let me finish this. So there's our graph. Is A is positive and N is odd. The left end goes down, right end goes up. If A is positive, N is even, they both go up. If A is negative, it's a decreasing function. Left end goes up, right end goes down, or both go down. So in our first example, we had, what can you tell me about this graph? What's the basic shape of this graph going to look like?
You can tell the end behavior that it's going to start with going down on the left and up on the right.
Yeah, right. On the left side, it goes down, and the right side goes up. So it's an increasing function. And we don't know what happens in the middle here. What else do we know about this equation? Yeah. We know that the y-intercept has to cross through that point. That's the only thing we know about the graph so far. How many x-intercepts is it going to have?
5.
At most 5. At least how many? 1. If it's odd, since one end goes down, one end goes up, it had one end has to cross. Well, yeah, but it has to cross the x-axis at one point. If we had a function like this, we know what about the end behavior? Yeah, because it's even, the biggest exponent's even, they both point the same direction. Since the leading coefficient is 1, positive, it's greater than 0, both ends point up. And again, we know that it crosses the y-axis at 3. That's all we know for sure. So at most, it can have how many x-intercepts? You have 6. That's the exponent. And at least 0. It's because in an even equation, it can cross n number of times, 1 time, or 0 times. So if n is even, we'll have at most 6 solutions and at least 0. If n is odd, we have n solutions maximum, and we have at least 1 solution.
I thought that it was the multiplicity that tells you if it's crossing or
if it's cross. Yes, that's if we have the multiplicity does tell us if it crosses, but it doesn't tell us how many times. Well, actually, we'll look at this. Okay, I'm glad you brought that up, because the example I give here is with this one. Okay, here it says since n is even, we can have at most 2, at least 0 x-intercepts. So the way we figure this out, we set the equation equal to 0. We have to factor this equation. Remember, this first term here is that letter, so x and x. X times x is equal to x squared. What do we know about the signs? Yeah, since the second sign's a plus, that means they're the same. They're both pluses. What times what is 1? When you add them, you get 2. So what are our solutions? Yeah, set those equal to 0. We're going to see it's going to be the same answer. X equals -1. So what does the graph do at -1? Does it cross? Does it touch? Well, we can't say probably, because here we have x plus 1, x plus 1. We can write that as x plus 1 squared. We have 2 answers. They both have to be the same. And anytime the multiplicity is even, it does what?
It bounces on the
Yeah,
x-axis.
it bounces. I like bounces better. It bounces from that point. So our graph at -1, the graph bounces from there. And since it's positive, it opens up. That's what a multiplicity tells us at that point. But again, the larger the equation, the more weird things it could do. It could bounce out a couple of times. Or if it's an even, it could bounce many times.
Yeah.
All the position.
And does that depend on the multiplicity of the rest of the zeros?
Yes, exactly. Yes.
Okay.
Whether it bounces or crosses depends on the multiplicity of the rest of the zeros. Exactly. And this is going to be the hardest part of this course, is figuring out what the zeros are. And we're going to ease our way into that. Let me see. Okay, there. Here we have the same thing. We have this new equation. This question number 2. Fx is equal to x to the 6th minus 5x. No, that's 8. That's 8, I'm sorry. X to the 6th plus 6x minus 5. So again, A is asking us for the maximum number of zeros. B, the maximum number of x-intercepts. And number of turning points. What's our degree? What's the degree of our equation?
8.
8. Yes, it's the largest exponent up there. So the maximum number of zeros we can have is 8. What's the minimum? Yeah, it went from 8 down to 0 because it's even. You can have an even function, even degree. You can start off at n. You can go down to 0 solutions. Same thing with the x-intercepts. 8 down to 0. but the maximum number of x-intercepts is the same as the number of zeros. How many turning points? Yeah, 8 minus 1 is 7. Okay, let's discuss how does this graph look? What can you tell me? Looking at the equation, what is this graph going to look like? Right, since this is even, both ends point up. And yeah, and the y-intercept is -5. That's all we know for sure. The rest of the zeros we can figure out later on. But now because our y-intercept is down here, and we know both ends go up, we know we'll have at least 2 solutions. Because one has to go from here, one has to go from there. So we'll have anywhere from 8 down to 2 solutions.
You could also figure that out by doing the intervals on the x-axis. Once you get your zeros.
Yes.
Okay.
Yeah. Once you factor this out, get all the zeros. Yeah. We just look at them and count them. But you're right. We just look at the equation now because that's down, the y-intercept's down there. It goes up. We know we'll have multiple solution sets. And yeah, we're gonna get to the intervals really shortly. Same thing for question number 3. F of x equals -5x minus that. Zeros, x-intercepts, turning points, and let's do a sketch of the graph. All right, so we have to figure out what is the degree of this polynomial.
6.
6, right? They tricked you. Always make sure that you look at it and you know where the intercepts are. I mean, the highest exponents are. That tells you how many intercepts. So the maximum number of zeros we'll have is 6. 6. How many turning points? N minus 1, so it's 6 minus 1, 5 turning points at most. So what can you tell me about this graph? If we rewrite it, very good. Yeah, so we know since it's even, both ends point the same direction. Since it's negative, they both point down. Since we don't have a constant, that means 0 is our y-intercept. So all we know from that equation is we'll have at least 1, at most 6 solutions, because there's 1 solution and who knows what else happens. Okay, now this next one, let me switch over to share my screen with y'all. The equation is f of x equals 1 over 4 x squared minus 2. Which one of these graphs, which one can it not be? Well, right off the bat, we know it can't be A or C because the degree of this one is 2, so it has to point the same direction. So A and C are out of the question automatically. Those two have degree odd. B is wrong because it's pointing down. That means the coefficient has to be negative and it's positive. So B is wrong. So it has to be D. So 1/4 x squared minus 2. We have f of x equals x to the 5th minus x to the 4th plus x squared minus 3. The degree of this equation is 5. So since it's odd, we know that both ends point different directions. Is it going up or are they going down?
It's going up.
Yeah, because the leading coefficient is +1. So that means the graph has to be an increasing graph. So down on the left, up on the right. So it cannot be D, it cannot be C, and it cannot be F. So it has to be one of these three. Well, B is negative, so that can't be right. E is negative, that can't be right. So it has to be A. And it also crosses the y-axis at -3. So the answer is A. Question number 6. X to the 4th minus 4x to the 3rd plus 11x squared plus x minus 5. The degree is 4. So that means both ends have to point the same direction. So we know that A, B, C are all wrong. They're both different directions. Is the leading coefficient positive or negative? Is positive. So it can't be E. So it has to be either D or F. Y-axis is -5. So this is -25, 20, 15, 10. This one crosses at -15. And this one crosses at -5. So which one is it? Has to be F because it crosses the y-axis at -5. So we know the basic shape of the graph already now. What do y'all think so far? Pretty straightforward, I hope. Number 7, f of x equals -x to the 5th minus 2x to the 4th. Now, so the degree is 5. And A is negative, so it's less than 0. So both ends point opposite directions. So it can't be A or C. And it goes down, so it's decreasing. It can't be A, but that's increasing, so it has to be B. In this one here, we can take it a little bit further. Let's look for the x-intercepts. We know we'll have at most 5. So what can we factor out of this automatically? What do both of these terms have in common?
X to the third.
X to the 4th.
What?
You can only take out what they both have. They both have at least 4. So we can take out x to the 4th. That leaves us with 1 more x here and the 2 there. We can also take out the negative. So if I give you an equation that looks like this, I broke it down to its smallest pieces. I can now look at the zeros and their multiplicities. So what are my zeros?
0 and -2.
Anywhere I see an x, I set that equal to 0. And I solve for x. There are my 2 zeros. What are their multiplicities? What's my multiplicity of 0?
4.
Yeah, is 4. And my multiplicity of -2
is 1.
Is 1. Together, they have to equal 5, which is my degree. So what can you tell me about this graph with the since we have the multiplicities here? If we drew the graph, we knew we would have at 0 and at -2. We have our x-intercepts there, our zeros. So what is it? What do we know about the end behavior?
It's going to be odd, starting up and going down.
So they have to go opposite, since it's odd, opposite directions. And since it's negative, the left side is going up and the right side is going down. So which one does it bounce? Which one does it cross?
The
Even multiplicities, even is bounce, odd is cross. So at 0, I have an even multiplicity, so it bounces off that. -2 has a multiplicity of 1, so that's where it crosses. So it looks something like this. So far, so good. All right, let me look at the next question.
On that question for the turning points, it's usually the degree -1.
Yes.
So we have one
Number of turning points is always n minus 1.
So that would mean going down, then up, and then back down.
Well, yeah, is at most, right? So here's 1. In other words, the number of turning points is number of vertices. So we'll have at most 4 vertices. We have 1 vertex there and 1 vertex there. The turning points are the vertices. Okay, let's graph this one. X squared plus 4x minus 12. Let's go ahead and graph that one. Yeah, so the degree is 2. So what do we know about our end behaviors for this polynomial? Yeah, it's the same direction. Since it's positive, we know both ends will point up. Yeah. What else can you tell me? Yeah, the y-intercept is at negative 12. So we're going to have how many x-intercepts? Yeah, here we have to have 2. Because we know the graph goes up, both sides goes up, and we know it crosses at negative 12. So since the graph's down here and it goes up, it has to cross at 2 points on our x-axis. We'll have exactly 2 x-intercepts. How many number of turning points? Yeah, so it's n is 2. That's the degree. 2 minus 1 is 1, and we only have 1. So our graph will look something like this. This could be the vertex. It doesn't have to be. It could be on either side, but it's just a rough sketch. So what exactly are our x-intercepts? So we set it equal to 0. In the first part, we have x and x. What about the number? What are the signs? Yeah, because it's negative. Second sign is negative. That means opposite signs. One's positive, one's negative. And the bigger number is going to be positive. So what times what is 12? When you subtract them, you get 4. 6 and 2. And 6 has to be positive. Now we set these equations equal to 0. So x equals negative 6 and x equals 2. So a better picture here. Our x-intercepts are there. Since it's a quadratic equation, it's a parabola, we know that halfway between these two x-intercepts has to be our vertex. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. 1, 2, 3, 4. So this is our axis of symmetry. Our vertex will be somewhere here. Negative 2.5. At negative 2.5. That means our y-intercept it looks something like this. we can find the exact location of this point from here at negative 2.5. So go negative 2.5 this way, 1, 2, and down 12 spaces. So we can plot that point. Because of symmetry, this point has a mirror on that point. This point has a mirror on that side. Yeah, that's if, yeah, we can find exactly, yeah, we can find the vertex by negative b over 2a. And does everybody remember where this part of the equation came from? The x value of the vertex?
Was it constant?
No, remember this formula?
The
quadratic formula?
yes.
If this whole equation here is 0 and gone, what are we left with? So if everything inside the square root, the radical is 0, we're left with negative b over 2a, which is the x value of our vertex. So this part here, that part inside the radical is pretty important. It's called the discriminant. It tells us the number of solutions we're going to have, or number of x-intercepts. The discriminant, whatever's inside the square root, tells us the number of solutions we're going to have. There are 3 possibilities here. It could be greater than 0. It could be equal to 0. Or it could be less than 0. Remember, this is what's inside the square root, the discriminant. If inside the discriminant is a positive number inside here, then we're going to have 2 solutions. Because then we can take a square root of it, then we have to do plus or minus. So we're going to have 2 different answers. We have 2 solutions. If the discriminant is 0, that part's gone. So all I have left is negative b over 2a. We're only going to have 1 solution. That tells us where the vertex is. Only works the quadratic formula, right? Only works the quadratic equations because it's from this quadratic formula. And if it's negative inside here, you can't take a square root of a negative. So we're going to have no solutions, no real solutions, I should say. We're going to have an imaginary answer. So that helps us also when we're given a quadratic equation, a polynomial degree 2, we can tell how many answers we're supposed to come up with. So the quadratic formula inside the radical is called discriminant. It tells us how many solutions we're going to have. If that value inside there is positive, we're going to have 2 solutions. If it's equal to 0, we're going to have 1 solution. And if it's less than 0, we have no solutions. No real solutions. This one's going to give us imaginary solutions. Yeah, I'm glad you fixed it then. It's the negative signs you have to be very, very, very careful about. Let me see, what was that last number we did? No, that's number 9. Let me see. Number 9. F of x equals x to the 6th minus 4x to the 4th. What is that graph going to look like? So we know the degree is 6, right? So we know since degree is 6, they can go, they're both the same direction, up or down. Yeah, a is equal to 1, which is greater than 0. So both ends are pointing up. And we have a y-intercept at 0. Can we find any more x-intercepts? Because yeah, this equation here comes from this. So which graph is it? Yeah, since it's an even exponent, it can't be A or C. It can't be D because it's positive x to the 6th, so it has to be B. So the answer is B. But we can go one step further. We can figure out what the exact x-intercepts are because it's a pretty easy equation. Set the equation equal to 0. What do both of these equations have in common? Yeah, they have x to the 4th. So I take out x to the 4th. If I take out 4 from the first one, I only have how many left? 2. If I take out 4 x's from the last one, all I have left is that minus 4. Inside this parenthesis, can we factor that any further?
X plus 2, x minus 2.
Very good, yes. Because 4 is made up of 2 squared. It's the difference of 2 squares. So the answer would be x plus 2, x minus 2. So our zeros and their multiplicities are what? What's my first 0?
Multiplicity is 4.
The first one's 0. So anywhere you see an x, set them equal to 0. If you just see an x out there by itself, it's automatically a 0 is x, a 0 of it. And it's a multiplicity 4. The next one is negative 2. Its multiplicity is 1. The third one, the answer is 2, and the multiplicity is 1. Because if you add up all the multiplicities, you have to get the degree.
Then after that, you put them in order, right? You'll put negative 2, 0, then positive 2, so you know if they're bouncing or crossing.
Right. So now we put them in our graph. We know from earlier that our both ends point the same direction. So we know from this one and from this one, they both go up. What happens at 0? Does it bounce or touch? It's even, so it bounces. And these two, it crosses. So it crosses here, and it just bounces there. So it'll look something like this. So we know at our endpoints, it crosses, 2 is -2, and at 0. So let's see what the options are of our graphs. You see how this graph looks? Looks pretty similar to ours. So if I was making up this test, I wouldn't give you these options to look from. I would say, give me this, they give me a rough sketch. And that's exactly how you'd figure it out. Okay, this is number 10. F of X, or this is H of X, but don't worry about that. We have X, X minus 2, X plus 4, and X minus 8. Roughly sketch the graph for me. So the degree is 1, 1, 1, 1. So the degree is 4. Whoa, yeah. So add up all the multiplicities, that tells you what the degree is. Since n is 4, we know that the end behavior has to be what? They both have either point up or down. Since if we look at the leading terms, x, 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 and multiply those together, that's going to be a positive, so we know it points up. If one of those x's were negative, then we know it'd point down. So just look at the leading terms. Since they're all positive, the answer is positive. So it means it points up. All right. What are my zeros? So the first one's at 0, so it's a dot there. How about the next one? Yeah, remember, it's always opposite. If the x is by itself, it's always the opposite what's in there. So it's 2, -4, and 8. What are their multiplicities? Yeah, they're all 1. So we have at 0, at 2, -4, and at 8. Those are all my x-intercepts. We know the end behavior, they have to go the same direction. They're both going up. Right. Since they're all odd multiplicities, they cross. So this one has to go down however it goes down. You can look at anything as long as it has this basic shape. That's our graph, like a big W.
What does multiplicity mean again?
Good question. Multiplicity tells us the number of same solutions. For example, if I factored out my equation and I got x plus 2 and x plus 2, that's the same way as writing x plus 2 squared. This is the multiplicity. If it's even, then the graph bounces at that point, at this x-intercept. If it's odd, the graph crosses at that x-intercept. So this is 1 and 1. If you add up all those, you get 2. So with this, we look at each one of these, since they're all odd exponents, we know that through each point, they're going to cross. Let's go back to the question on the computer. So our picture matches which one?
W.
Has to be B. It can't be A because both ends point different direction. Can't be C or D because they point, well, D points different directions. Can't be C because it points down. It has to be B. We have 4 x-intercepts and they both go up. Why can it not be D as well? We have 4 x-intercepts, 2, 3, 4. Well, one side's going up, one's going down. But how many vertices do we have? How many turning points? There's 1, there's 2, there's 3, there's 4. The number of turning points is always n minus 1. Since it's a 4th degree equation, we have to have 3 turning points. This one has too many turning points. Number 11. Number 11 looks like this. F of x or g of x doesn't matter. Negative x minus 4 squared. So what's the degree of this equation? Yeah. The highest exponent is 2, so n equals 2. Since it's an even degree, we know that the end behavior, both ends point the same direction. Is it up or down? Because the coefficient is negative, they both point down. What's my 0? Right, 1, 2, 3. Yeah, so take the inside here, set it equal to 0, we get x equals 4. And they both point down. The graph looks something like this. It just touches at 4 because it's an even degree, an even multiplicity. So it bounces at 4. So looking at our options, It has to be which one? Has to be B, because one A and D are opposite directions, so it's not odd. So it's either B or C. Since it's negative out in front, it has to be pointing down, so it's B. And the last one for this section, number 12, f of x equals 8x cubed minus 6x squared minus 32x plus 24. So what's our degree? Our degree is the biggest exponent, which is 3. And 8 is positive. The leading coefficient is positive. It's an increasing function. Both ends point different directions. The y-intercept is positive 24. And the x-intercept. Let's see, we can solve this one out. Because we have how many terms in this equation? We have 4 terms. So let's try the grouping method. If you have 4 terms, we can try to use the grouping method. Put the first 2 in parentheses and the last 2 in parentheses. If there's a negative in the middle, put it inside the parenthesis. Now, what can we factor out? Out of the first one, what do they both have in common? Right, 6 and 8 both have a 2 in common. And I took out 2 x's, so they both have at least 2 x's. So to figure out what goes in the parentheses, whatever you factored out, divide inside. So 8 divided by 2 is 4. And I took away 2 x's, leaving me 1. 6 divided by 2 is 3. And I took away all the x's. How about the second one? Okay, we take out, since there's a negative here, we take out a negative. They both have an 8 in common, no x's. So if I divide by 8, 32 divided by 8 is 4. Remember, I took out the negative, so I got to change the sign. No, now what that means, we're still factoring. So what do both of these have in common? They both have a 4x minus 3 in common. Remember, we have 2 terms. And both terms have the same thing in common, so we factor that out. What do we have left inside the parentheses? Whatever's in front goes in the second parenthesis. Now, whatever's left in front, after you take out what's in common, whatever's left goes inside the second parenthesis. Yeah, what do they have in common? They both have a 2, don't they? So I take out, divide by 2, I got x squared. 8 divided by 2 is 4. Put the 2 way on front. How about that one? We have a squared term in front. We have a minus sign. Is the last number a perfect square? Yeah, 4 is made up of 2 times 2, which is 2 squared, which is the difference of 2 squares. Which makes it x plus 2, x minus 2. Remember, we said equal to 0. Take each of these, anything that has an x. This one doesn't have an x, I don't worry about it. So anything that has an x, I set it equal to 0 and solve for it. So x is equal to positive 3 over 4. So I add 3 and divide by 4. X equals negative 2 and x equals 2. So my zeros and multiplicities, these are my zeros. And their multiplicities are all 1. Because if I add up the multiplicities, I have to get the degree of the equation. So what are my zeros? What points do we know for sure? The 0 is at 3 over 4. So it's right there at 0.75. There's one at negative 2. And there's one at 2. And since they're all odd multiplicities, the line crosses at each one. And we also know that it crosses at positive 24 in the y-axis. So remember, we also know that both ends point different directions. So this end's going down, it has to go up, crosses through that, back down, and back up. It looks something like that. I mean, it could be stretched out more, but that's the basic shape of it. Because we have our intercepts at negative 2, 2 and 3/4. They both have multiplicity 1. They all have multiplicity 1, so they crosses. The left end has to go down, the right end has to go up, and it has to cross through the y-axis at 24. So which graph is this? Which ones can it not be? Can't be A because it's, let me see, So since it's a third order equation, leading terms positive, it can't be A because both ends have to point different directions. And A is positive, so it can't be C. So it's either right, because we figured out the multiplicity is 1, so it has to cross. This one bounces, so it can't be B. So it crosses at 3 points. So it has to be B. Has to be B because we have 3, both ends point different directions. We have 3 X-intercepts.
Because it's on such a small scale, though, B, the y-intercept is wrong. But on B, because it's such a small scale, going under, and that could be 24 where it crosses the y-intercept on B.
On D? Yeah, but we notice here it's not crossing, it's bouncing at only 1 point.
But
Yeah.
it just so
Yeah, that would give it a multiplicity of 2.
Right. We could zoom in further and you see it doesn't cross. And remember, it's also at 250, so each of these numbers are pretty spread apart.
check the answer.
It's missing.
See if it likes B. I think it's gonna like D. Because if you look even closer, you can see it does go past the x-axis down.
Does it go past?
Yeah, it's just such a small. See, it's going under right now.
Oh, yeah, it is. Yeah, if I see anything, if you see anything down in the homework, these graphs are awful. Oh yeah, it can't be that one because it goes past positive 2. Yeah, I mean, that's giving me a headache looking at. Okay, that was section 2. Let's look at section 3 really quick. Oh, actually it's 3:15.
Yeah, I have just a quick question?
Yes.
On number 11, the one you did with g of x equals the negative x minus 4.
Okay, number 11. Yes.
Yeah, I noticed that when we originally made the drawing, we kind of never had the lines cross the y-axis. But how would I find the y-axis using the original formula? Like I know you set it to 0 and you could insert 0 for x, but can you do it with this question?
You could.
But if I insert 0 for x, it gives me 0. I don't. How would I?
If you put 0 for x, then we have -1. -1 cubed is -1. Negative of -1 is +1.
Oh, okay. So it would be 0, negative. Okay, 0.
Right.
Negative. Right.
Yeah, and this also gives us a horizontal shift of +1. So moves the horizontal shift over 1. And
Okay.
it's a negative. So again,
All right, that makes sense. Thank you.
you're welcome. Yeah, because I don't like when they cram these huge equations into these teeny tiny graphs. Okay, let's get our toes wet with division. Chapter 4, section 3, polynomial division. So let me give you a quick discussion. Okay, it's giving us this example. It's asking us, is x plus 4 a factor of this polynomial? There are 2 ways we can determine this. Well, 2 basic ways, and there's one of them that could be 2 other ways. We can use long division, we can use synthetic division, or we can use substitution. Now, if it says, is this polynomial, is that a factor of this bigger one? What that means is, if I was to factor this equation all the way out, would this be one of the options? Well, that's what we're going to determine. That's how we use these three. So let's look at long division. Let's review long division. (46) divided by 3. Let's make it 45. The way we can rewrite that equation is like this. This is how division used to be taught back in the old days. Whatever's on the bottom goes in front, whatever's on top goes inside the division box. 3 goes into 4 how many times? Once, with how many left over? Yeah, so 3 times 1 is 3. And bring down 3 goes into 15 5 times. We subtract, we get 0. Does that bring back some memories of division from elementary school? So now since we're, yeah, so when the first one, what times 3, how many times 3 go in 4 is once. So 1 times 3 is 3. We subtract those, we get 1, and then bring down whatever's left. So now how many times does 3 go into 15? 5 times, but 5 times 3 is 15. Subtract them, you get that. So this answer, that's your solution.
See why I got it wrong. I was trying to like put the remainder of the carrier somewhere up top. That's the way. Why I
No.
remember it.
Yeah, yes. Yeah, no, there's no carryover just yet. So the way you test it, the answer times the denominator should equal 45. So we have 45 divided by 3. Does it equal 15? Let's check. Multiply both sides by 3. 3 times 5 is 15. Yeah, so the answer is 15. That's long division. So in other words, what does this tell us? 15 is a factor of 45. It also tells us, since we have an answer with no decimals, we also know that 3 is a factor of 45. This is what's important, what we're looking at here. This is a factor of 45, and that's a factor. So in other words, 45 can be written as 3 times 15. Those are the factors. Also, it's important, the remainder equals 0. If the remainder is equal to 0 using long division or synthetic division, then we know it's a good factor. If the remainder is equal to 0, then we have 2 factors of the numerator. That's numerator over denominator. Okay, that's from how we did in elementary school. Now we're doing polynomials. The same concept applies. Here's our numerator, our basically this is what it's asking. Our equation, 101. If I divide it by x plus 4, will the answer give me a remainder of 0? If it does, then that's another factor of this bigger equation. It also tells us that x plus 4 is a factor of that equation. So let's rewrite it. Whatever's on the bottom, x to the 4th, 3x cubed, 2x plus 101. Now with long division and polynomials, we only are interested with the leading term. So the leading term is x. What times x gives us x to the 4th? What times x gives us x to the 4th? X to the 3rd, because we have 1 here, we need 4, so we add 3 more. So again, look at the leading terms. What times x gives us x to the 4th? X cubed. Now, whatever this is, multiply it to both of these. So x cubed times x is x to the 4th. X cubed times 4 is a positive 4x cubed. Okay, remember what we did here. 1 times 3 is 3, and then I subtracted them. So I have to do the same thing here. I have to take this equation and subtract it from the top, which means I change both of the signs inside there. Now add x to the 4th minus x to the 4th, they cancel. Negative 3x cubed minus 4x cubed, they're both negative. 3 plus 4 is 7, x cubed, and bring down everything else. So again, look at the leading term, figure out what goes in there, multiply it to both of those, change the signs, and add them. So the next step, again, look at the leading terms. What times x gives me negative 7x to the cubed? And negative 7x squared. So now I take this number, negative 7x squared, and multiply it to both of those. So negative 7x squared times x is negative 7x cubed. Negative 7 times positive 4 is positive 28x squared. What do I do with the signs next? I change the signs and add. Change the signs, then add. Negative 7x cubed plus 7x, they cancel. Remember, the first term should always cancel out. 28x squared plus 1x squared is 29x squared. Bring down everything else. Repeat the process. What times x gives us 29x squared? Positive 29x. So now I take the 29x and multiply it to the x plus 4. 29x times x is 29x squared. 29 times 4 is 126x. Change the signs and add. Negative 126 plus 2 is negative 124x, and bring down the last one. Repeat the process. What times x gives us negative 124x? Minus 124. So minus 124 times x is minus 124x. Minus 124 times positive 4 is negative 496. Change the signs and add. Positive and negative 124x cancel. 496 plus 101 is 597. That's your remainder. So is x plus 4 a factor of that polynomial? Is not a factor of that big old long polynomial. Because we don't have a remainder of 0. Now, it's the same step over and over. That's why I always look at x. What times x gives you the first leading term? Once that's gone, the new leading term is negative 7x. What times x gives you negative 7x? And then multiply them. It's a lot of writing, yes, but it gets the job done.
Switching of the signs.
The reason you switch sign, because here, when I took 1 times 3, I got 3, and then I subtracted them. I changed it from a positive 3 to a negative 3 by subtracting it. So that's what's happening here. When you subtract it, you're actually changing the signs, taking the opposite of that number. So as each of these numbers, I have to change the leading term so it's opposite. Okay, that's one way. You want to do another example, or show you the next synthetic division and substitution before we move on? All right, let's look at synthetic division then. And then we'll do another problem all 3 ways. So here we have the same thing. We have x to the 4th minus 3x cubed plus x squared plus 2x plus 101. Again, we're asking, is x plus 4 a factor? Yeah, this is going to be synthetic division. Synthetic division only uses the numbers. There are no x's when we do synthetic division. instead of using this division box, we use that division box. That's what tells us the difference between long division and synthetic division. Long division is upwards, synthetic division is upside down. So since we're using synthetic division, I put that. Notice, we only use the numbers. So inside here, only put the numbers of your original equation. So what's the coefficient of x to the fourth? X cubed. So this is the x to the fourth column, x to the third, x squared, x, and constant. This is very important because let's say I didn't have an x squared term. Instead of putting a 1 here, I'd put a 0 since there are no x squared terms. I put a 0. If you're missing a letter, a variable with an exponent, you have to keep that place allocated by putting a 0 in its place. Okay, now what comes over here is take the solution, our factor, set it equal to 0, and solve for x. X equals -4. So in other words, solve this for the outside number. That's just setting it up. Now comes the easy part. I think it's easy. All this is going to involve is multiplication and addition. So always bring the first term down. Multiply -4 times 1 and put it there. -4 times 1 is -4. Add -3, -4 is -7. Repeat the process. -4 times -7. Negative and negative is a positive. 4 times 7 is 28. Add straight down. 1 plus 28 is 29. -4 times 29 is going to be negative. 4 times 9 is 36. Okay. -116 plus 2, that's a negative. It's a 114. Let's make sure this is right. -7 is positive 28. 29, that was 36, 8, 9, 10, 11. Okay. Repeat the process. -4 times -114 is a positive. 4 times 4 is 16. 4 and 1 is 5. It's 456. Uh-oh, I made a mistake.
It's 456.
Yeah, so the remainder here is 456. No, we didn't add them. So no, it's 7, 5, 5, 5, 7. Because remember, we have to add those, and this is our final answer. If it's not 0, then it's not a factor. But I must have made a mistake on the first one. Because now, if we look at this, remember, this was used to be x to the 4th. Now it's x cubed minus 7x squared plus 29x minus 114 plus the remainder of 557.
Yeah, the synthetic one is correct. On the first one, we got 126 instead of 116.
Yes, yeah, I just see it there.
Okay.
So in this one should have been
557.
Yeah, and that changed everything else. But see, which side's easier? Because this one here required a lot of writing. This synthetic division is a lot easier. And let me show you the third way. And then from there, we'll do another example, all 3 methods. Now, last one is substitution. So remember, so in this one, the first step, take our equation, set it equal to 0. We get -4. Plug that into our function. So I put -4 to the 4th minus 3, -4 to the 3rd plus -4 to the 2nd plus 2 times -4 plus 101. -4 to the 4th is 4 times 4 times 4 times 4. This is 16 times 4. That's 64 times 6. It's 384. -4 cubed. -4 cubed is -64. -4 squared is +16 minus 8, 101. Negative times negative is a positive. 3 times 64 is 192. And just add them all together. So 394 plus 192 is 576. $576 plus 16, 592. 5 minus 92 minus 8. 584. Now, all we have to do here is, since this is not equal to 0, it's no solution. I mean, it's not a factor. Oh yeah, I have to. My car's almost going to get towed because of that. So those are the 3 different methods we'll pick up next time after Easter. And we'll do some more examples. So those 3, and then this is everything we know about division. Plus from here, we can now start pulling apart larger equations and using synthetic division to figure out what it's made up of. Okay, everybody, have a happy Easter, safe, be good, hope you found a lot of eggs, and I'll see you all on Monday.
Thank you.
Hey, bye, everybody.